trying to tell people about your organization and all the exciting things that you guys are doing. So
thank you very much. Right, let's get this open. Do we have anyone else joining us, Sanjay, or is it just...
No, it's just going to be you and me. I'm well versed with how far we've already talked. I'm interested in looking at that Dark Knight that I sent you as an example, and if you can kind of walk me through, you know, how will it work? Like I'm the client, if you will, and I'm basically, you know, going to go from A to Z. Show me like how far can I push the buck basically with your system basically.
Yeah. So let this just load up. I'll show you the workflow that I went through. It took 5 minutes to show you those kind of outputs. Just waiting for your Revit model to open on my PC. So the way that the process would work is you would have your Revit model. You would have that house type. You would have maybe a different configuration. So it depends if you're going to be doing 3 or 4 of those in a lot. If you're going to be doing different configurations, I know you had a 2-bed and a 3-bed and maybe a 4-bed side by side and maybe back to back. Depends how you can configure and lay those out. That would be your project. So if I actually load this up, now that I've got my screen, let me share screen. Let me know once you can see my screen.
Yep.
Can you see my screen? The Revit model?
It's coming up. Okay, there we are. Okay.
That's fine. So yeah, we've got your Revit model. Quite simply, all I did was take this and I turned off everything that I don't care about in Kope. So that is all your annotations, your toilets, sinks, that sort of stuff at the moment. No, we don't actually care about those for now, and get your model back into this sort of state. So what I noticed was your model has a curtain wall over on this side in your model. It's not the end of the world. It's just something to note that Kope won't handle those.
Sorry, what is it that Kope will not handle?
It's called a curtain wall. So if I undo what we just did and swing around to the other side, you've got like a full glazing system on this side. So there's just nothing for Kope to frame on that side. It's all self-contained curtain walling. So once I redo that and turn those off, you'll see
empty.
That geometry is just empty. We just
got it
in there to frame around. So from here, we simply export the IFC file, and we've got some settings in here that we prefer. So down here we have a design transfer view. We would export that out, and then once that file was processed, let me get.
It has to be IRC file format. It's not DWG.
IFC,
IFC file format. Okay.
It has to be a 3D model. So rather than using the native Revit geometry or ArchiCAD geometry, IFC is like the PDF of 3D BIM. So we use that file coming into Kope. So then once that's loaded in, it gets loaded into Kope. What you then have is, let me just turn off framing model. Just turn these bits on. This is your building in the way that Kope sees it. So your walls with openings and the internal walls, the external walls. What we then do is we target external walls and internal walls. So if I come into the rules, what we're looking at is look for any wall type name that has WD 2x4. So that's all of these external walls that you had. If I go to internals, something very similar, look for all the walls that have this as a rule. So simply doesn't include ply in the name, was basically the rule set that came in there.
So primarily, if I'm understanding your thought process, you'd take a BIM model and the 3D model in IFC, and then separate out the external and internal wall, and external being more of load bearing, and the internal being non-load bearing walls. Is that what you're going through?
No, you can separate them by build-up type. So if you've got a non-fire rated wall that has a different board and framing system, 30-minute fire rated, 60-minute fire rated, you would have these as separate element sets. So you'd have your internal non-fire rated, internal 30 minutes. But what you're trying to identify is what is the different construction systems that we're looking to apply, and just break those out into here. Now, the reason we do that here and Kope doesn't automatically recognize them is because every project does it slightly different. They use a slightly different name. They use different parameters. So it just allows you to chop and change and move stuff around on a project by project basis.
So your software is really going by standard naming convention of
No. Nope. We don't enforce a standard naming convention. That's why in here, you can tell it whatever you want to look for. So this could be wall type 1. Your wall types are WD2X4, but it could be wall type 101, wall type 102, wall type ABC. So that's what this is flexible and allows you to search for.
Okay.
So yeah, depending on who the project team are, they can have as many or as few as they want. From there, I then added in our benchmark light gauge steel framing system. Now, this is what we would work with yourself to build out this product. So this is our benchmark. This is like a generic steel framing piece of logic, but we would work with yourself to understand what are the profiles and sizes and gauges that you work with. And when we come into this, if I come to external walls, you'll see why. So in here, under boarding, you have the boarding types that you would have in your system. So the plywood was the outer, the wall board, so your gypsum board was internal. Again, do you use 5/8 of an inch and 1/2 inch? Do you use moisture rated board, etc., etc.? This is what you as a product would have your drop downs in here. So you might not use OSB. You might only use plywood rather than OSB. So OSB just wouldn't be an option in here that your team or a customer would even be able to select. Now, if we get down to framing, the same thing. So if we come to the framing, you would have what are your framing sizes and studs that you'd be using. So, you know, this is 3 inch and 5/8 on a 15 gauge, etc., etc. So this can be, we have some customers that have a couple hundred options in here, sort of stud configuration and size and profile. And this demo, we just have the 3, but you could have all of those in between. So from what I could tell from the Revit model, you had the same stud size, I believe. It was more the ply build up on the outside differed. And I think the gauge, so your overall size of stud didn't change. It was just the gauge that was put in through there.
So if you look at the gauge and the mods and stuff like that, like the way it's designed, it's designed by 6 mods. Are we able to break it down, like identify the configuration of each and every mod, where I can see exactly how many panels would be needed by the mod, or do you go by the whole building envelope?
So we do the whole building, but we would be able to break it down mod by mod if there was a data point that we could separate it out by that. So assuming that this is a mod, this is a mod, this is a mod,
yes,
this is a mod.
That is true. And does your software not detect that it is a mod?
No. We might be able to. I just don't know where the information was in this Revit model. So if I turn this back off, like there's nothing in here that says that this is module 1, module 2.
Yeah,
module
we have it in our engineering drawings, but that's fine.
So that's where we would need it as a data point in the BIM for us to be able to pull that out. If it's just a piece of text on a drawing, that doesn't go anywhere. We would need it in here to say what module it was part of. So typically you'd be breaking this into a twin wall if that was the case. So maybe it's these walls that are actually twin walls that go in one mod and another mod. So we would be framing those out. So you would say that this wall is module 2, And in here, you might have a bespoke parameter that says we're part of what module part you're in, and this one would be module 1. So all these rules, we would then be able to apply them like that.
Okay.
But it's not in that file that you sent me. So once I was there, I then, went through, you set these up. How do you want to deal with the header and seal conditions, et cetera, et cetera. So again, these would all be preset based on the way that you do the module fabrication. And then we simply hit run. So we would hit run.
Before you hit run, what about the module connections and stuff like that? Do you also take that into consideration, what those connection types are and stuff like that?
We can do, but you need to tell us what those connections are. We won't drive that on for you. You have to tell us.
Oh, it's not. You cannot detect it from the Revit design.
There is nothing in the Revit design for us to detect.
Okay.
So you would have to tell us that if you've got one module and another module side by side, the relationship between those two modules, this is how we resolve it. And then Kope would apply that solution. Okay. What Kope won't do is tell you this is what we believe you need for your system.
Got it. Okay.
So once that's applied, I'm not going to hit wrong because it's already been applied. If I just come back in and turn the base model off, what you then end up with is this boarding and framing. So if I grab the internal walls here, what you can see is we then have every piece of ply. If I actually just hide these, you'll see that this has then all been applied. And then you've got your steel framing members in here. This is the wrong size, but that's just because of the configuration had a smaller.
But let's just hold on for a quick second. This framing method or these frames, I don't know if because we had another engineering company kind of use Structsoft and build these wall panels. Are these frames detected because somebody had already done the framing system, or Kope builds this framing system?
Kope builds all of this framing system.
Oh, so what Kope introduces this framing system, integrates it into the Revit model, basically.
So this is in the Kope model at the moment. So if I hide this, so if you see this wall, there is no framing in there. That is simply a piece of geometry that says I am a wall of this size with a door in the middle.
Okay. And then what does Kope do when it looks at this door, basically?
So Kope recognizes the door. It said, so first you have the model, great. The target is look for internal walls. So it finds all of these walls. What it does is it goes wall by wall and it says, okay, here is a wall. Now, what do I need to apply to that wall? And it comes into your product, looks through the internal walls configuration. So it pulls up this information and says, okay, for a header condition, I need to apply this framing system. For the sill, you don't have a sill here because it's a door, but if you had a window, you'd have the sill. For the door jamb and the base condition, these are the rules and configurations that I need to apply. So a bent base track, you can continuous, so just put your base track all the way through, etc., etc. And for the rest of the walls, these are the framing logic and rules that I need to apply. I'm doing.
When you say I need to apply, somebody of domain expertise needs to do that, or Kope can automatically apply some out-of-the-box rules?
We can create a default. So you would tell us what you want your defaults to be, and then it would apply those. But yeah.
Okay. And so after you apply, what does the outcome look like? Let's use this wall as an example right now.
So that wall then gets applied. So if I go back to the models, turn the internal walls on, turn that one off. I've already hidden the extra bits of board, but then what it's done is it's worked out, here is the door opening. So in order to place the board around the door opening, I have to allow the 6-inch gap to stop any cracking that happens with drywall. I have framed out the door jambs, I've framed out the headers to your rules, and then it's gone through and worked out where the stud spacings need to be to pick up board pickups and follow that.
So this is powerful and very genius. So let me ask you just out of my naiveness, I'm just doing a comparative analysis. Structsoft, does it do something similar like this, or Structsoft is only looking at more structural calculation because it also does panelization, right? Structsoft.
Yes and no. Structsoft does something similar. It will place framing. You can tell it what you want it to do. The way that Structsoft works, though, is you've just done the internal walls. What you have to do in Structsoft is break the walls up into individual panels. So at the moment, this is, you would have to tell Structsoft at this junction, this is how you want the walls to run through. So you would say, I want this wall to be the leading wall, and I want to split the wall at this point. This corner, I want this to be the leading wall, and I want this to be the child wall. On this corner, this will be the
I see. So you have to give a lot of, you have to almost construct the wall panels, but Cope is automatically through AI already constructing the horizontal, the vertical, whatever, those braces, and also the spaces that is needed, right?
Not necessarily through AI. We use our, what we call computational engine. So our rules of geometry and how you handle geometry like that. You could tweak this. You could actually tell this, actually, I want this wall to run through, and this becomes the child walls on this junction. But Cope will, given the hundreds and thousands of different corner junctions that we've run through, it recognizes that this is your primary wall typically. But once it's run, you'll be able to jump in and edit that if you really want it a different way around.
Okay.
So then what Cope does is it goes wall by wall, following the rules, following all the framing, and our panelization process. So if I actually, let me just double check if I had panelization. So we don't even have panelization turned on, so to speak. So this is traditional frames in this context.
Can you turn on the panelization and see what the magic happens here?
Yeah, it is hoping that this doesn't break. So under our panelization rules, we've said that you can go up to a maximum length of 15 foot. So I'm going to guess that okay, so now it has actually changed these into separate panel pieces. So if I go into our assemblies and I colorize, let's do
So you can group by certain wall panels, basically.
So these are now the panels, yeah. So this is a good example of how Cope does panelization. It will start here. And in our panelization, we have a target length of 15 foot. So it will start here. It will come to 15 foot and realize that it's landed in the middle of the window opening. Now, you can't normally do a panel with a window opening like that. So then what it's doing is it's looking at what's my minimum and what's my maximum length. So then what it does is it draws back, works out, well, how do I handle the window framing? And it will keep drawing back to a point where you can then position the panel break before it starts a new panel that can handle this window condition. If it was pulling back, and there was another window here, and it gets to a point where now it's less than the 8 foot minimum, or whatever minimum it was, it would go the other way. So it will carry on going this way and say, I'm allowed to go up to 20 foot. And that now lands here. So it would then do a 20-foot panel and say, that's how you would break this wall out. And then it would move on with the small piece that sits on the end. So what Cope is able to do, and this is where Structsoft doesn't do this, is we're able to do that on the fly for all your different wall types at the same time. So the way that Structsoft and NWF work is you would say, I'm focusing on my external walls at the moment. I need to tell it how each corner junction detail is going to be prioritized hierarchy-wise. And what you then need to do is tell it, and I'm going to break my walls here, here. So you would go along and you would break it yourself at the 15 foot or smaller or longer, depending on what your system type allows for. and you would do that manually. So you'd break the wall into all the individual panels.
But Cope is automatically through the computational engine is depending on the maximum length that you provided, it will start cutting those panels and showing these might be your best ideal panelization approach, basically.
So this is one approach. So yeah, it's kind of doing some optimization as it places those panels. What we then have is an optimization engine itself. So within here, I can actually click on optimize. And what we then have is like an optimization engine in here. So what this allows us to do is say, what are my objectives and outcomes? So I want to have as few panels as possible, and I want to have as few panel types. In order to drive that, I'm going to tell it, you are allowed to vary let's go down to panelization. You are allowed to vary the minimum panel length, the maximum panel length, and the target panel length.
Okay, let's just pause here when we say minimum and maximum panel length. Now, there are certain machines like FrameCAD or FrameTech. There are so many different machines that do this whole panelization, right? Is this adhering to that length sizes, or maybe you have to set it as a default depending on your machine?
You would set that. So your machine might be able to do 40 foot. Cool. Your maximum panel length would then be set to 40 foot in your product.
Got it.
So then, yeah, so maybe you would leave your minimum and your maximum off. You just say they are the same rules. They would be the same. But what we're going to do is allow Cope to vary the target length. And what that will allow Cope to do is blend this value here, and it can run 30 instances at the same time. And what it would do is it will take that logic, it will run it, and then it will have different target lengths within that range of 30 different increments. And it will start to see, where is the optimization happening? Like, is it not 20 foot is the optimal? What we found out is 17 foot is actually your optimal panel to get you the minimum number of panels placed and also the minimal number of panel types. And what this does is it spits out all 30 options for you, and it will show you that the best weighting. So if you think on a scatter graph, it will tell you that your best one is here, and your next best ones that are on the optimization curve are options 7 and options 23. What you can then do is actually use a human eye and tweak some factors if you wanted to and override that. But this would spin up multiple instances on the cloud at the same time and blend them back together at the end and tell you, here's your results. Okay. Now, this you cannot do in Structsoft. This you cannot do in MWF because it relies on the desktop and it can only run one computer at a time.
So Structsoft can do that, but not MWF?
No, neither of them can do that.
Okay, so I have a question in terms of now, like optimization. If you go back to that window of optimization, there are multiple thoughts. Like the top two, I just got a quote from a metal company giving me a quote for the top two mods. It's working out to be $20 a square foot, but the bottom mods are turning out to be $40 a square foot. And I had an aha moment, and I thought to myself, maybe there's more steel and the way it's designed, it's more beefier. And as you're talking about placing panels and panelization types, is it also doing some sort of a recommendation that lesser wall panels or lesser steel so that the cost is getting reduced of the final envelope as a delivery, as a package? Is it able to do that?
Yeah, it can do that. So if you look here on the right-hand side, you've got all of your output metrics. So in here, we've got framing weight as a whole, and you've got total length, I think, is in here. Framing area and framing length, I think we have. Because if you come into the bill of materials, so the parts list here, no, get rid of the mark, what you have is every single piece and part in that framing and boarding activity. So if I group by framing type, what you then end up with is the overall lengths and areas of, and the total roll-ups of all of those values. So what is the total area of wallboard? 2,300 square foot. If we go to think it is.
So that's still adhering to the length. But how is it adhering to cost factor where you don't have too many studs at every corner being applied? Because I think that the way the panelization companies, wall panels charge you is by the weights, how many pounds. So how are you reducing the total pounds? I mean, a length can be a 15-foot or 20-foot. That's more orchestration of assembly, but finally the price is getting dictated by the pounds until I might be missing something.
So again, so you can have costing in here as well. So if you've got, we actually don't have costings turned on our example here, but you would have here as cost, and you have minimum and maximum cost. Obviously, dividing a panel, the way that the costing engine works, it can be added as a project fixed variable, a project fixed or variable calculation based on, for every project, start with $10,000 as a fee. So regardless of the size of the project, there is an admin fee of $10,000. Then for every panel, there is a $5 fee. And then for every linear foot of steel of this profile size, there is a $1 cost. So then what Kope's doing is, as it's going through these metrics and varying them, the cost is changing. But what you need to tell it is, I want you to be able to blend panel sizes, stud spacings, jam configuration options. And what it will do is it will work its way through and say, of all the different inputs and variables that I'm allowed to do, this is the combination that has generated the least cost. Now, what Kope will also do, depending on how you set the product up, is it will recognize that some conditions cannot go with other conditions, and that would just be a null and void option. So that would just flag out as non-buildable. And that would say, actually, if you go with a lower gauge, but a higher stud count, that higher stud density, yes, you have more steel, but that steel is so much cheaper because of the thinness of the steel and the gauge, that actually means that overall that works out cheaper. So whilst you have more studs being placed, it is a lower cost gauge, which means that in the round, because you have fewer panel types, blah, 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 that ends up cheaper.
Yeah, what you just described, sorry, go ahead.
So that's what these studies are. So what you do here is, I've just ran one option. If I duplicate this, let me just rename this to option 2. As an example, what I would be doing in here with my internal walls is leaving this non-panelized and let that run. What you can do, give that a second to run, is then come and compare option 1 and option 2 side by side and actually see, only show the differences. Oh, sorry, I've kind of jumped the gun a little bit on that. Give it a second to warm up. But basically, you'd be coming through here and working out what is the difference in, so like as an example here, your embodied carbon, your non-panelized obviously doesn't have a secondary stud. So your embodied carbon on a stick build, just for the materials, is lower. But what you need to factor in is then your labor cost and that sort of stuff, and actually the waste that would be accruing on site and adding in those costs. So there's a number of things that you can have in here that you can compare side by side. So if I come down to costs, it might be on a different tab, but you could be running these side by sides as we don't have cost to turn on this one, but you'd have cost here as a value, and it would tell you this one is more expensive than that one. But
yeah,
again,
that graph that you just showed is super critical, where somebody can kind of compare cost and the structure, because you want to build, like, you know, if you've got 8 building floors, you want the most optimal way of, from a the pound perspective, and also labor. You mentioned something about the labor. Can I add a certain cost of how the labor might get impacted because I've got more panels or whatever the density? If I'm tweaking one variable, how is the labor kind of getting impacted, type of thing? And what's my bottom line, the envelope of this building? How do I, bottom line, everybody's trying to look affordable, and cut costs. So how do I reduce the cost? Can I do side-by-side comparison of if I take option 1 approach, my labor is so much, option 2, my labor is so much?
Yeah, we just don't have cost turned on our benchmark product here, but you would have a cost value here, and you'd have materials and labors included in that, and you can actually compare a side-by-side as options. So what you'd be able to say is for a stick build, your labor rate is $5 a square foot for installing drywall, and $7 a square foot or linear foot for installing steel framing. I have no idea what the actual numbers are. You would include that as a metric into the costs, and when you change it, it would tell you here's the impact of doing that. So for every panel, you can include a lift, you can include what's the install rate, etc., and you could say we like a building of this size. If you've just got 3 mods or 6 mods, like you'd install that in a day. Like there shouldn't be any harm getting 6 mods to a site and craned off of each lorry and installed in a day. Question there is how much does each mod then cost? And that comes down to the factory. And what you're trying to do is optimize the size of the mod to fit on the back of a lorry, and then help the factory be as efficient as possible with their installation of the pieces and parts inside that. So if you're getting some repeatability, maybe they're happy. Other manufacturers, they don't care about repeatability because every single panel has to be signed off regardless. If it's 10 of the same panel, they would sign off every panel as if it was a unique panel each time. Others sign off 1 type and that's it.
Yeah.
Great, we're done with them. We don't need to sign off the other 9.
Yeah, the repeatability might be good if we're doing these multi-stories and missing middle 8 units.
Yep.
If we have 1 bedroom, 2 bedroom, or 3 bedroom mods type of thing, and we're repeating those panels and sort of cutting it. Now, we talked quite a bit about panels and optimization of panelization and things of that. What about modularization? Like if I want to use best of both, this is more leaning towards assuming it's going to be a panelized approach, but can I take this similar train of thought of saying mod A versus mod B can become cheaper because of this configuration that I'm doing on mod A versus mod B?
Yeah. So what Kope won't do, and something that we have no intention of doing in the near future, is taking a building design and telling you this is how you do your mods.
Okay.
You would still have to break it into mods in the first place. What Kope can do is if you have the mods in there, you'd then be able to optimize each mod, and it would tell you that this is where you're gaining some advantage. So realistically, what you could do with this is actually just lay these out 6 mods side by side and let Kope run across all 6 mods at the same time and see where you get repeatability. What we're able to do is actually allow a little bit of variation in the model. So if we come into constraints as an example, what we're actually able to do, I think it's in this activity. No, we don't have it in here. What we're able to do is actually allow you to basically wiggle the openings up to a certain distance. So it could be as much as 6 inches, or it could be as little as 1/8 of an inch. What you can tell Kope to do is, I want you to move door openings ever so slightly. And what that will then be able to do is tell you if you move, let's see if I can find a basic example of this. No, because you only have about 4 walls. Here as an example, if it just so happens that these wall lengths, what it will be able to tell you is if you move this door 2 inches to the right or 2 inches to the left, whatever, this panel here could now be the same as this panel here.
Mm-hmm.
So you get some repeatability in your panel types. And then by doing that, that means that your off shot here could be the same as the off shot here and the off shot here. So you now have 2 repeated panels, and you've got a second, and a second. So you now have 2 panel types, that are being used repeatedly. And that panel type here that's filling in the end is actually the same type of panel that goes, I don't know, here as an example. Now, on just a single house type, that's not, it's a little bit obvious how you really do this in the real world. But when you have 3, 4, 5, 10, 12, 20 different house looks and layouts, it's actually a really good way for you to see when there are some opportunities to optimize it here. By making some small adjustments here on a door opening by a few inches means that I can reuse that panel type across 4 other modules. And we did that with Winton Homes. That was one of the exercises that they asked us to look at. And that's something that we're digging into their product book.
Got it. Now, we've talked about just interior walls, exterior walls, and stuff like that. Can we do optimization of the entire house or building, take the next level of what that bill of material?
Ceilings. Yeah. So at the moment, your next category would be ceilings. So actually doing steel framing for ceiling systems. And then from that, we'll be getting into flooring systems as the category after that. At the moment, it's walls. We have done other system types, but the steel framing sector that we're basically going after now, we are building out the logic for ceilings and floor joists next. So you can't do that today, but you will be able to in the not so distant future.
But what about insulation and cladding?
Oh, that's within there as well. That's already in here. So it was just when I applied this, I didn't have any insulation inside the walls. But if I go back to boarding and say
Can
that
you apply a certain logic just as a template logic and show what sort of insulation would be needed so that we can get to the cut list, if you will, to the specificity, the length, and all that stuff based on the wall panels?
So if I do the insulation, I'm just going to add in 3.5 inches of insulation. Now, this might actually be a bit too big for these walls. But as an example, if I then group by this category, I'm just going to hide all my framing and hide all my boarding. That's all of our insulation now in the model. So that can be your fiber fill board. That can be your
rock wall.
Yep. If I then open up the insulation, you then have every piece. So let me grab.
Oh, so this is almost like a bill of material. I can go to a vendor and place.
Oh yeah, this is a full bill of materials in here as well, and this can all be exported out to Excel. So every piece and part is in there.
What about cladding now? If I want to tack on cladding on
it, we haven't really done cladding. The reason being is that tends to be the most architectural sensitive piece. What you could do is just do a surface area of cladding, and it will tell you you've got 2,500 square foot of cladding. What it won't typically tell you is every single piece of board unless you wanted to. If you wanted to invest the time in placing framing like that, we could. But to date, we've not had anyone say, yeah, jump in the cladding piece, just because it tends to be so architectural that.
So now since you have the steel framing and the walls and stuff like that, are you also able to apply some general out of the box features of how many screws or how many connections? Let's say we feed a connection type. We're going to just say, this is my connection type. Will it, through business logic, automatically say at every wall how many connections would be needed and what sizes and all that stuff?
Yep. So what we can do, so again, we've had another customer with their activity say that for every, so the way that Kope understands this is a top track, this is an end track, this is a stud, this is a jam stud, a header, a king post, a noggin, whatever. What we can do is then encode that for every junction that Kope generates, increase the count to 2 screws. So you always have a screw count. For every stud to base track, just do 1 screw. For every end stud to base track and top track, add in a bolt. So you can start to actually do that. Now, what won't happen is Kope won't create that geometry, because that's not what Kope's intended for. But what it can do is at least factor in those counts. The way that we've partnered with the Teklas and the Revits of the world is that junction handling piece happens outside in the fabrication tools like Tekla, and that's where you then have the junction handler in the Cope plugin for Tekla, and that's where it will start to put in all your dimples and swages and all that sort of stuff in Tekla. You wouldn't be doing that in Cope, just because that's not the intention of Cope. It's supposed to be a design.
So you mentioned something very interesting, that you have that seamless integration with Tekla, and Tekla is doing more of the structural analysis. So
You
am
can
I
do that.
hearing you say that all the creativity, like you said, this wall panel, if you were to move 2 feet, then it can be duplicated. It's also then synchronizing the structural calculation real time with Tekla. I mean, you can paint and draw all that you want and make the panel more, duplicatable or optimal. But then are you also syncing that this model is not going to crash because now I've given such creativity, but it's not adhering to the structural calculation? Are you getting that confirmation real time, or that's a separate exercise?
That's a separate exercise. So we do not do any structural calculations in Cope by design. These tools generally are driven by people who have an understanding of what is happening, so they don't create anything that's completely out of the wild. But the speed at which you can apply the still framing in Cope and push it to Tekla and run the analysis, you will see very quickly what you can and can't do. So you would come back into Cope, you might tweak the stud spacings to say, yeah, we've seen that has failed. What we're going to do is actually go back and restrict now what the framing conditions were. So we can only have, where were we? Boarding, framing, stud spacings at 1.4. Actually, we're going to have to go to 1.8, and we would test that and we would rerun it. You then have version 2 now. That's now been rerun, and all of the frames and studs have moved around as required. So that's a completely different solution. So you'll see now that your stud spacings are completely different. We would push that back into Tekla and then run that quickly in Tekla and validate that a 30 inches is actually allowed.
Now,
so there is maybe a plan in the future that will bring some of that directly into Cope, but as of today, we don't do any analysis like that inside Cope.
So the exercise is you have to export this like an IFC and importing it in Tekla, or is it a different file type that Tekla might recognize?
So you can export an IFC file. You can also export a Revit and Tekla compatibility file. So what you're creating there is a Cope interoperability file, and then you have Cope's plugins in Tekla and in Revit that take that file and then place native geometry.
I also saw you got Trim BIM. That's more Tremble. That's more virtual reality. Is there any correlation of what you're designing here that on site that somebody can plug and play and the numbering is already done, or that's a separate exercise here?
Yeah, that all happens in Trimble. So obviously Tekla is owned by Trimble. So what you can do is actually pull from Autodesk's ACC cloud. So actually pull IFC files directly from there, or you can pull Trimble files or IFC files directly from Trimble Connect, and we can push them back up as well. So we can push them directly to those cloud spaces. Or you download it locally and you upload the IFC file there yourself. But there is that ability as well. All of the numbering, machine code files, that sort of stuff, that happens in a Revit or a Tekla.
So it happens in that CAM file. So all this design that you've done, like how seamlessly can you integrate right up to the end-to-end construction? Like, how do I take all this knowledge, the design, and pass it on? I know you're already showing you can move it from Autodesk construction and then Trimble, and then that can go into the physical world basically, and also go into the CAM file. Do I have to produce a separate CAM file for the machine for a frame CAD, or you already have those automatic exports, or there's got to be another treatment done so that it's machine ready for a frame CAD or a frame tech? Are you seamlessly integrated with those file types?
Nope. You have to go through a Tekla or through a Struxsoft and Aaronic system in order to do that. So we don't go directly to a Howick or a FrameCAD direct inside Cope. We work with the Teklas and the Struxsofts and that sort of stuff, so you can actually create those CAM files there, just because of the amount of additional uplift in penal use wages and details and that sort of stuff happens in that software. You know, it's just a matter of time. They've been doing that 20 years. There's an awful lot of nuance to those tools. What we do is speed up the process to get them to be able to get into the CAM files in the first place. So for a matter of spacing and timings, what we're seeing is one of our customers just last week worked on a 440,000 foot project. They said that would take them about 3 weeks with Struxsoft and MWF to actually generate all the panels and get the content delivered. With Cope and Tekla, it took them 3 days. So just a massive time saving internally. Obviously, once it's in the machine, it takes as long as it takes the machine to print all the studs. There's no speeding that process up. But what we're able to do is get them out to tender in days instead of weeks.
What's the delay in Struxsoft and Tekla taking 3 weeks and you're doing it in 3 days? Is it that automation that you showed or panelization and all the business rule engines that immediately from a Revit file creates those suggested panels? Is that what is the main key sauce of Cope?
Yeah, that's one of it. The other one is it's cloud-based, so we're not limited to what your PC can do. A lot of those tools are decades old now. A lot of them are single-threaded, so they don't actually able to run multiple calculations at the same time. They just have to do one stud after the other, whereas we can divide these walls up and run each wall on their own. This is a massive time save doing it through us, and then we can run on multiple optimizations in parallel, whereas, as I say, they don't do the panel divisions. They have to set that all up manually. It doesn't do the junction handling. They have to do that all manually. It's just a very, very good at what it does as a single process. But when you start to scale it, it's multiple single processes running one after the other, and it just draws out as a long length of time. Whereas we're able to stack them on top of each other in multiple cases. As an example, what we've just done with your internal walls and your external walls, and I did that in one run, and I just changed it to be 3 different systems. You know, we did the 1.5 feet, the 1.8 inches. We changed the board size. We added the insulation, and it redid everything at the same time. That would probably have taken 45 minutes to an hour just to reconfigure Struxsoft to then be able to apply it. So we then apply it in a few seconds on a building of this size. On a bigger project, it takes much longer. But it would have taken them 45 minutes just to reconfigure everything they needed to then apply the insulation and handle that sort of stuff with those options.
You know, your software package, if I were to go to a competitor, who's the closest that comes to your competition? I know Struxsoft has got a separate, but who's the closest that comes to you?
Yeah, they're the closest in that space. We have, because we're horizontal rather than a vertical, you know, in Revit, you could be using Dynamo, but you would then be your own computational expert writing their own software there. There's not a like for like of Cope on the market, but what there are is there's lots of pieces that come together to make something like Cope. So yeah, there's not really a like for like competitor that we've come across in that space, to be honest.
So you're really focused more on that panelization and steel framing, and can you do it for wood also, the similar thing?
Yep.
But what about the MEP?
BC housing and their Dash program. Cope powers all of that program.
Which is the Dash program?
So BC housing and their digitally accelerated social housing program, Dash. Cope is the underlying tech that sits there placing all these pieces for BC housing.
And that's in Canada, Dash?
Yep.
Okay. What about the MEP and things like that? If I need a cut list and bill of material for MEP and pipes and things of that, how does Kope do that?
You won't get the actual MEP. We're a couple years out from doing MEP. A lot of that is going to be driven by the work with the hospitals that we do here in the UK. What you will get with MEP is the builder's work opening and coordination. Like I've noticed in your model, you don't have any openings for ventilation or ducting, electrical wireways or anything like that. Again, if you have an opening that says it needs to be 4 inches by 4 inches, Kope will recognize that. And you can tell it if an opening is more than 2 inches, you need to frame it. If it's less than 2 inches, ignore it. It will just be an on-site drill. And Kope will, if it recognizes the opening in your wall, it will then frame that as a services opening. What you'll also be able to tell it is this is a fire rated opening. So if you're going between a kitchen into a living space, as an example, you need to have a damper or you need to have something like that. And that's a different way of framing it. It would frame that accordingly. But we don't have the actual ducts and the pipes and that stuff in Kope at the moment. We will have it. It's just not there at the moment.
Do you have a software that we can integrate that data and almost make it like a unified integration where me as a builder, I want that whole orchestration using Kope? And are there any other plugins that we can use from your marketplace?
Yeah. Revit does all of that. You can use a plugin called Convoy that will actually place builder's work openings directly in the model. So if you say I have a pipe in Revit and I have my wall, at the moment it will clash, it will just go through. Convoy will recognize that interface clash and then place an opening.
And will it create a cut list for that? Like how long the pipe should be? Convoy will do all that?
Revit can do all of that for you. It's just not the nicest way of seeing it. It'll tell you every piece and part within your MEP model. It's just not the nicest.
Is there a user-friendly software that allows, because I'm trying to do a kit apart for MEP and HVAC, like create build sub assemblies and orchestrate that. Are they softwares that will allow me to do that level of detail, granular level of detail? I know Navisworks does, but that's more like a 3D modeling, but it's not going to give me engineering sizes, pipe.
Navisworks doesn't do any design work. That's just a clash detection software and sequencing software. So that would tell you that the pipe is clashing, but it won't give you a deliverable list. It will just tell you here's all the pieces and parts in the model. If you need to draw something, it'll be a Revit, or there's much more expensive software like CATIA and stuff like that. But a single seat license for CATIA is like £20,000, so $40,000 just for a single seat. It's the same software used to design aeroplanes, to design cars, to design.
Oh, CATIA?
CATIA, yeah.
CATIER?
CATIA.
CATIA.
But yeah, that is a.
Is that like a DFMA software?
How would I describe that? Not DFMA. It is component level design. So like I say, you can design an aeroplane in CATIA. You can also design a car. You can also design a building or a bridge.
Is it by Technia? It says design software by Technia.
Yeah.
Here.
But yeah, like I say, that's a behemoth of a piece of software that will do what you're looking for. I don't know a simple user-friendly version of that, unfortunately, at the moment.
But CATIA can design all these component level things, and we can kind of orchestrate that, basically.
Yeah. You can also go into, if you want to keep in the Autodesk realm, I think it's Inventor is that one. So it's like a component level piece.
What's it called? Inventor?
Inventor.
Inventor, Autodesk Inventor?
Yeah, I think that does your component level stuff. But yeah.
Oh, okay, yeah, I know about them, yeah.
Sanjay, I'm conscious of time because I'm in 4 minutes. what would you like next steps to be?
I'd like to talk to my engineering team. I'm going to share this video with them. See, how does it apply in context of whether we take the panelized approach. I think so far the takeaway that I'm doing is that your is really ideal if your construction is heavily relying on panelization approach as opposed to modular. That's what I'm sort of gathering out of it. And if I need to immediately give somebody, what's it going to cost to build your envelope, like in a panelized approach, this might be a great estimation opportunity. Want to ask, there are some companies that give it as a service of like this quotation of panelization. Do you have a service rather than me buying a $10,000 pound, like a crawl, walk, and run? Like I give you a print and you charge me by number of files or whatever, and you give me a quote on that?
We do, but that only comes with an enterprise license. So we have partners where we work with alongside them to work on their projects. For a one-off project, that's not something we would really build. You would have to have your own system and logic in Kope, and then we would run a pilot with yourself on a project-by-project basis, but you would have to have a Kope license in order to do that. What I would say is with your modular piece, what you would have is, if you had your building already divided into the modules, i.e. the walls are going to stop here at the module end, and you had your 4 walls and then the internal walls, and you had module 1, module 2, module 3, Kope would do the same thing. All we see is you have a module that is 12 walls within a cuboid. Kope then says, cool, within that module, this is then actually how we would assemble the module with all the pieces.
Are you also giving me the sizes and inches and things like that only for light gauge steel, or also taking into consideration like HSS steel or the thicker gauge and stuff like that? Are you giving me that?
So we can do structural profile as well. What we won't do is hot rolled steel or anything like that. So we won't do any heavy sections. You'd want that done elsewhere and then fill in the other pieces. Because again, it's structural. It's so structural analysis driven that it makes sense. By the time your structural engineer has modeled that out, you just use the steel framing that they've already got. But everything in between those, then Kope would be doing that.
So mainly LGS or cold form steel, basically.
Yeah.
Okay.
At the moment.
Okay.
So
this gives me a great idea. Thank you so much. I know we're almost top of the hour. Let's connect through the email as next steps. I'll share this recording with all the team and educational purpose, and I'll keep you posted.
Brilliant. Have a good day, Sanjay. Thank you very much. Bye now.
Sorry, आपका टीवी टाइम ले लिया मैंने. How is your health?
Getting better.